Okay, I'm going to go through question 17 and 21 from the past paper. Pythagoras, Pythagoras, Pythagoras.
Are you ready for this?
Alright, I hope you enjoyed that. Back to another epic maths video. Today we're going to be recapping some work we did while we were back in school, independent tree diagrams, and then we'll look at dependent next lesson. So this is where we draw a tree diagram where we've got successive events and we want to combine them. So playing a teddy grabber, then playing a penny drop, or the classic example is taking 2 coins out of a bag or 2 counters out of a bag. The probability of kind of picking 2 of the same colour coins, we wouldn't be able to do that through our classic probability methods. We would need a tree diagram for them. Before we even look into what this question is asking us, there's things that we need to know about tree diagrams that happen constantly. So these, the numbers on the branches, they'll always equal to 1, and that is no matter where we are on the diagram. And what I mean by that, so if this is 0.2, this must be 0.8. They must add up to 1. And just on their individual branches, not all 4 of these, just on their individual, where they kind of join together, here, here, and here. Anything that spans off that needs to add up to 1. So this would be 0.7, because 0.7 and 0.3 gives me 1. And this would be the same game. Even on this bottom one, that's just after we lose instead of win, so it would be the same probabilities up there, and that's something you see quite a lot. The second thing we need to know is when we move across the branches, we multiply. And what I mean by that is, well, in this second part of the question, work out the probability that James wins the teddy grabber and also wins the penny drop. Well, we would go win and win. So this is the path we want. These paths I would put a cross by because that's win, lose, lose, win, and lose, lose. That's not what we've been asked. We've been asked for win and then win. So to calculate this, we do 0.2 times by, because we're going across the branches, 0.3. So 0.2 times by 0.3, that will be 0.06. So the probability that he wins both, the probability that he wins then wins, would be 0.06. Or you might know that this is a 6% chance. You don't need to write that though, a decimal is completely fine. So on to this second question. We need to calculate the probabilities ourselves. And the way you know it's an independent question is by it will say something like this. So she takes a sock and she puts it back into the drawer. And what independent means is no matter which one we take from this first sock or this first choice, it doesn't actually affect the probabilities in the second one. If I didn't put that sock back, the probabilities would change here because there'd be less socks in the drawer and there'd be less black ones or white ones depending on what we picked first. But in this case it doesn't, so it's a little bit easier. We don't need to do that extra working. So the probability of black would be, well, there's 5 of them, so 5 out of the total, so 8. And the probability of white, well, there's 3 of socks that are white, and out of 8, 8. So let's start filling in our tree diagram. 5 out of 8, 3 out of 8. You can see these add to 1, so it's looking good. Because it's independent, she puts it back in the drawer. Even if she picks a black sock, there's still 5 left in the drawer. And there's still 8 in the drawer overall. And that logic applies to every single one. When we work out the probability that the 2 socks are the same colour, well, we want that to be black, then black, or white, then white. These two would be black, white and white, black. They're not the same colour. So always organise it, put some ticks by the paths you think are useful. So then we're going to multiply, so 5/8 multiplied by 5/8. That gives me 25/64. Then I'm going to do 3/8 times by 3/8. That gets me 9/64, multiplying top by top and bottom by bottom when we multiply fractions. When we get to this stage, we add these probabilities. So we don't multiply again, but we add them. So we do 25/64 plus 9/64. So that's going to be 34/64. And you don't need to simplify in these questions, but if you did want to, we could say, well, that's 17 out of 32 as our answer. So either one of them is fine. You don't need to simplify unless it specifically asks you to. Okay, so a bit of a bigger one, but similar. So we can either win, draw, or lose. Well, we need to figure out first what it is like to the probability to lose. So that is 1, take away 0.6, take away 0.3. That's because they need to add together to make 1. 0.6 and 0.3 make 0.9. So 1 subtract 0.9 gives me 0.1. Winning, drawing, or losing this match doesn't affect the second match. So we would fill in the same probabilities for each one. You can see this has got 3 branches. A bit harder to draw, but if it's drawn for you, it's just as easy to use. So we need to work out the probability that the team wins both matches. So that's going to be win, win. So just that branch. Everything else, we won't have won twice, so we don't want that branch. So we just want to do 0.6 times by 0.6. That equals to 0.36. And that can just be our answer. You could also say, well, that's 36%, but you don't need to. So in all honesty, if I was doing this question without having to draw that, I wouldn't have drawn the whole tree diagram. I'd have just drawn the 2 branches I needed, or at least just this top little section where it goes off the win. Because I know as soon as I drew or lost, I don't actually care about anything down here. So I'd have only drawn this section, because I know that's all I wanted to look at. And then final example. So there are green and blue counters in a container. Kevin takes a random counter from the container. He replaces the counter. So that's how we know this is an independent question. Kevin takes random a second counter. So, well, if it's 7/8 to be green, it must be 1/8 to be blue. So I'm going to fill that in. It's just the same down here. So work out the probability that Kevin picks counters that are different colours. Well, blue, blue, they're not different. Blue, green's different. Green, then blue, that's different. And green, green is not different. So we need to do these calculations. 7/8 times by 1/8. Well, that's going to be 7/64. And then I need to do 1/8 times by 7/8. Well, again, that's 7/64. And then at this stage, remember, I add them, so I add this to this. So that's going to be 7/64 plus 7/64 equals to 14/64. Remember, when we add, the denominator stays the same. And you don't need to simplify it, but if you choose to, you can say that's 7/32. You can always write it as a decimal, but I think fractions are a lot neater, and you don't always have to worry about what you're rounding to, because that's always the question everyone asks. How many decimal places? Well, if you write it as a fraction, you're not concerned about that. Okay, that's it from me, and remember, the width.
Nice.
Hopefully that has helped some people.
Wait! Don't forget to subscribe!
I can't